Okay. Good afternoon and a blessed new year to everyone. As we seek to make our journey in maths prosperous, we are having some lovely interactions today. We're going to have one of our first marathon in a series of marathon, and I hope all will participate and will come to enjoy the beauty that mathematics is, seeing that it is easy and that it is fun. All right. Not much else said. We are ready to go. All right. All right, so we're going to be taking a look at a nice little warm up with some of these multiple choice questions that we have going from 2004 to 2015. As we know, many of these questions are going to seem familiar because you might see some of them over and over in bits and pieces. Here we go. We already know the rules relating to the multiple choice questions that we are going to be finding the best selection for an answer. Question number 1 says 0.45 may be written as, and this is asking us to write the answer as a decimal. And if we take a quick look over on the markboard here, 0.45. How would we approach this? First thing we want to do is count. The first thing we want to do is to count the amount of decimal place, and we're going to count that this is 1 decimal place, 2 decimal place. Now, the fact that it is 2 decimal place, it means that we're going to divide 5 by 100, right? Which is a multiple of 10. And as you can realize that it has 3 place value, but more importantly, we notice that there are 2 zeros here, as there are 2 decimal places in the number that we're using. All right, so from here, what do? We can clearly see that 45 is a multiple of 5. And 100 is a multiple of 5. All right, so let's go 5 into 45. That will give us 9. 5 into 10. So we are left with 9 over 20. And if we go back to the question, that answer is A.
Hey, Sir Grant, you hear me?
Say that again?
Yeah, man, you hear me?
Yes, I am.
Can you share your... I'm not seeing your screen with the paper.
You're not seeing the screen with the paper?
No.
All right, so from here, hold on.
That is, we're not seeing it on YouTube.
It's not. Oh, hold on. All right, so let's go 5 into 45. That will give us 9.
Mr. Grant?
Yes.
You need to share the specific window that you're actually looking at now, which is
Let me go back.
Yes.
Is it being seen now? The paper that I'm on now, is it being seen?
Yes, I'm seeing it.
All right. One more question. Sorry. All right, so we're seeing the screen, all right? Good. Let's go again. Taking a look at this very same question. Number 1. All right, so as we just said a while ago, we noticed that the 0.45 has 2 decimal places. So we're going to choose that multiple of 10 that has 2 zeros. That is, of course, 100. All right. And then we can clearly see that 45 ending with a 5 is a multiple of 5. So 5 can go into it without leaving a remainder. We can see that 100 ending with a 0 is a multiple of 5. So 5 can go into it without 5 into 45 goes 9 times. And 5 into 10 goes 2, along with the 0 makes 20. So we obviously have 9 over 20 as our answer. And of course, we can clearly see that that is A. All right. That being said, let's go again. Let's take a look at number 2. The number 3.14063 written correct to 3 decimal place is, and decimal place just simply wants to count the numbers behind the point. So this is 1, this is 2, and this is 3. However, even though they ask us for 3 decimal place, we need to do a check in the 4th one to see if the 3rd decimal place is going to change or remain. All right? So if it is 5 or more, we're going to go up by 1. If it is less than 5, then we remain as is. And as we can clearly see that there's a 6 here, so this 0 is going to go up by 1, so it becomes 3.141, and that answer is, of course, B as in ball. Let's take a look at number 3. Now, in number 3, they ask us the number 3076 written in standard form is. And in standard form, what we want to do is we want to have only one whole number in front of the decimal point. So if we assume the decimal point to be here, it's going to jump 1, 2, 3 places. It's going to jump how many places? 3. So that will give us 3.07 3.076 times 10. Every time we jump the decimal point, that's multiplying by 10. But what power of 10 now? All right, we made 3 jumps. So obviously, this is going to be a 3 right here. And then we need to know whether it is positive or negative. Now, here's my question. The number 3076, is it greater than 1 or is it less than 1? If you say that it is greater than 1, then make sure this number is positive. Positively bigger than 1. If you say it is less than 1, as in a fraction is less than 1, then the power is negative. All right? So it is either positively greater than 1 or the power is negative. All right? We're going to go again. So, okay. The answer for this, D as in dog. All right, here we have number 4, sorry, on the screen. It says the fraction of the circle which is shaded is, so let me take the screen up so you can clearly see the fraction. Now, this is a circle. and pi, or to be more correctly stated, a sector is cut out from the circle. Now, everybody should know, if you have paid any attention to geometry, that every sector comes with an associated angle. And that angle tells you how much out of the complete circle has been allotted to that sector, whether it is a major or minor sector. In this particular case, the shaded portion is a minor sector because it's the smaller angle of the entire 365 degrees that makes the circle. Now, that 365 degrees is the complete circle, but we notice that on the major side of the sector, the angle associated with that is 285. So we ask the question, if 285 is for the unshaded side, how much is it for the shaded side? And if you guessed it, you should guess that the answer is going to be 75 degrees out of a possible 360 degrees. Now, do we see that answer there? I think some breaking down is required here. Of course, the 75 ends with a 5, so it's a multiple of 5. And the 360 ends with 0, so it's also a multiple of 5. So these two are multiples of 5. So 5 into 7 goes 1. 5 into 25 goes 5. So we have a nice little 15 right there. 5 into 36 goes 7, remainder 1. 5 into 10 goes 2. So this is 72. So we have 15 over 72. But can we, I'm just thinking, can we reduce this any further? Let's say we take the value 3, right? 3 into 15 goes 5 times. 3 into 7, 2. Remainder 1 to make 12. 3 into 12 goes 4 times. So we get 5 over 24. And when we take a look, the answer is right here at the top. Not so bad, eh? I should remind us that these things are easy. And another reminder, when we're practicing these multiple choice, we should recall that we're not allowed to use calculators in multiple choice. So your best bet is to practice these out of your head. Try knowing your timetable. Try knowing a few little tricks that can help you to reduce the time that you take to go through these things. And of course, familiarity goes a far way in making these things easier, because sometimes by virtue of your familiarity or doing them so often and so frequently, what will happen is that a pattern begin to form in your head. And when you see the pattern, your brain snaps. Well, not in a bad way. It's triggered. It's a better term. It's triggered to the right procedure to get the answers as fast as possible. The exact value of 2 when divided by 0.01 raised to the power of 2 is, all right, let's take a look as how we can approach this. Okay. So when we talk about 2 divided by 0.02 and it is squared, which is mean that is 0.01 times 0.01. Now, of course, I know that when I'm multiplying these things around here, I'm simply going to add up the amount of decimal places. So this is 1, 2, 3, 4. 4 decimal places. So 2 divided by 0.0001. And that is clearly because 1 times 1 is 1, and all these other zeros. All right. Now, So you're probably asking the question, how then do we divide by this? And let me show you a little bit of indices here, if you're ready. Are you ready? All right. So I can jump this back. 1, 2, 3, 4 to put the 1 in front right here. So this is going to be 2 divided by 1 times 10. But this number 0.001 is less than 1. So we give it a negative power. Remember, when it is positively more than 1, you put the positive power. Okay? This one was not more than 1. So it has a negative power. Now, what will happen is that 1 into 2 is going to give me 2. Yes. But because I'm dividing by this power, I'm going to have to subtract the power. And if I subtract a negative power, it becomes a positive power. So it is 2 times 10 raised to the power of 4, which means that it is 2 with 4 zeros then. The power of 4 means that there are going to be 4 zeros. So if I write 4 zeros, what will that look like? Ladder, dada, dada. All right? And the answer is 20,000. I'm guessing that some of you were thinking that it's going to be this, but remember, I did not say multiply, I said divide, right? And the smaller the number you divide by is the larger the answer. And this number was extremely small. All right, so we're going to take a look at other questions. So in a school, the ratio of the number the ratio of the number of pupils to the number of teachers is 20 to 1. And notice it says pupils to teachers, so the 20 matches to the pupil and the 1 matches to the teachers. If the number of pupils is 840, how many teachers are there? And this is what we call direct proportion. Direct proportion means that one thing varies directly as the other one varies, which means whatever number you would multiply to change one number, you multiply the other one by the same exact number. Okay, let me just say, if I had 3 and I triple it, which is to times it by 3, whatever that other number is that is associated with the 3 must also be multiplied by 3. That's direct proportion. If I had halved it, then I should have the other number associated with it. That's direct proportion. And then we have what is known as inverse proportion, where we would do the opposite. So if I half one, I'd multiply the other by 2. You know, if you turn half and you invert it, you'll get 2 over 1, which is 2. So that is how the inverse proportion comes in. But this is not inverse proportion, by the way. This is direct proportion. I just segue there to just give you a more rounded understanding of what is taking place. All right. So when I compare this, now I'm saying 20 students compares to 1 teacher. But I'm told that there are 840 students or pupils. So if this is the pupil side, over here we have P, and the teacher side right here we have T, then I must put the 840 on the pupil side. And then over on the teacher side, I don't know what that answer is. I'm going to put a little comment here to mean teacher, right? And let me use another color to bring this out. And what I'm going to do now is what we call, once you set up this, the first case up here, I call it the base case. This is the case that shows you the simplest relationship you can find, or the simplest relationship that has been given. And then we add the other one now with the part of the case missing, where the question is asked or where the problem is found. So you cross multiply like this. And that means t multiplied by 20 is going to give us 20t. And that is going to be equal to 1 times 840, which of course is 840. And from here, we can simply do solving for solution, as most of us know. And what is going to happen is that we need this t to be by itself. And there's this 20 right there multiplying by. What we want to do now is going to do carry the 20 across and do the opposite on the opposite side. So the t will remain. The same 20 that was multiplying by the t is now going to come on the other side, opposite side, that is on the right-hand side, and it's going to divide. It's going to do the opposite of the multiplying that it was doing before. And of course, the zeros would cancel. That means 10 into that and such and 10 into that. When I say canceling of zero, I mean when we divide by 10, the zeros would go. And then 2 into 84 is going to give us 42. So 42 teachers would be needed for 840 students if we were to keep the ratio of 20 to 1. And 42 is B. Right? B. That's right there, B. All right. Let's move over to question number 7. In question number 7, we see here where we have a set P, right, with elements 52, 77, 91, 124, and 217. Now, 3 members of the set P have a common factor, which is what? So they have a common factor, which is, all right, so let's just break down these factors in a little bit. So 52 ending with 2 is obviously an even number. Yeah? And we can start by saying this is 2 times 26. 26 is also an even number. So I'm just going to put the times here and say it's 2 times 13. All right. Now that we have ended up at all prime numbers, right? I'm not going to do that anymore. And that's a 52. Let's go to 77. Obviously, in 77, I can see 7 times 11. And these are already both prime numbers. All right. 91. What's common for 91? All right. Nothing clearly comes to mind right now. Let's come back to 91. 124, obviously an even number. So 124, that's going to give us 2. Sorry. 2 times 62. And 62 is even. So it becomes 2 times 31. And 31 is a prime number. So that kind of stops right there. 217. Okay. So if I just box that there, so you know that these are different factorial breakdown for these. And let's take a look at the 217. I don't have any obvious figure that goes into it. I know it's not an even number, so 2 does not go into it. So we can start with the number 3. Because if I start into 3, 3 goes into 21, 7, but then 3 cannot go into 7. So it's not possible for the 3. All right, if I use another number, it cannot be 5. It did not end with a 5 or a 0, so it's not divisible by 5 outrightly. How about 7? 7 into 21 would go 3. And then 7 into 7 would go 1. So that's 31. All right. So this is 7 times 31. All right. And then this 91 now. Let's take a look at this 91. All right. So 3 cannot go into it because 3 into 9 goes 3, and then 3 cannot go into 1. Cannot be 5 because it did not end with a 5 or a 0. So we try to use 7 then, right? 7 into 9 goes 1 time. Remainder is 2, so that makes this 21. 7 into 21 goes 3. So this here would be 7 times 13. All right. So they said that 3 of these have common factors. I notice that 31 is in 2 of them.
Go straight.
But I noticed that 7 is in 3 of them. 7. 7 is in the 7 times 11. 7 is in the 7 times 31. And 7 is in the 7 times 13. So the answer here is B. All right. And it's a matter of knowing your prime numbers. If you're not so familiar with your prime numbers, especially your prime numbers going from 2 up to 97, then you're liable to have issues, all right, when these come. But now that you have seen it, you know you have been exposed, and I'm strongly doubting that you're gonna be having any problem. All right, here we go. Around the ring, doing our thing. All right. Now, obviously, this question reeks of graph, are more so not graph. The fact that they have images on it and they're naming them, this is transformation. Item 8 refers to the diagram below. This is a transformation type diagram. I am going to minimize the drawing so that you can see both the question and the diagram. So here we go. And it asks, in the figure above, triangle OPQ is mapped to triangle OP prime and Q prime. Now you're probably wondering, when I say prime, what am I talking about?
Optimus.
So I'm going to circle. So you see these little accents here? We call them prime, and they are used to refer to the image point, all right? So what I'm saying is that O is the original O, but this P here is not the original P, it's an image of P. And this Q here is not the original Q, it's an image of Q. That means what Q would look like after undergoing some kind of transformation. And sir said, you said, like, sir, like, what kind of transformation could there be? And I would tell you that you can have reflection, translation, rotation, enlargement. And as in this case, if you look on the list of answers, you'll see the thing there, shear. And that is the type of transformation where they stretch out a shape. Don't see it much on CSEC papers anymore, but hey, comes to you here is widening your knowledge and strengthening your brain muscles. You want to be strong. You want to be brilliant, don't you? All right, so we're going to be strong and brilliant right now. All right, so as we go back to this, in the figure above, triangle OPQ, where's OPQ? OPQ, so that's this triangle here. This one, that triangle right there is OPQ, is mapped onto OP prime Q prime. So they share the point O together, and this is it. Now, there's something that I notice, right? I notice that the triangle OPQ is 4 by 2 in a sense. 4 by 2, right? And I notice that the triangle OP prime Q prime is 4 by 2. It's the same size triangle. Another word for saying that is that they are congruent. Congruent, yeah? Same size and the same ratio of the sides, right? Okay, so it's the same size triangle. So it's not an enlargement. I know it's not enlargement because the size has not changed. All right? I know it's not shear because the ratio of the sides does not change. Okay? So that leaves me with translation, reflection, and rotation. All right? Now, anytime there's a reflection, you're going to find that the image points are going to be facing the object points. But here's what I'm going to do for us. I'm going to connect the points. All right, I can't connect O to O because it's already O, but I can definitely connect Q to P. Hold on, let me see if I can get the fancy lines. Hold on. All right, so here I go now. I'm going to connect Q to Q like that. And I'm going to connect P to P like this. And you're saying like, sir, so like, what's the big deal of doing that? Well, if I should change color and say what's the big deal of doing that? If I'm going to find the reflection or rotation, it's going to be based on what I'm doing here. And I'll soon come back to how you differentiate the translation. So I want to find halfway between these two lines. And then what I want to do is, so I'm going to estimate halfway now just to show something.
Go. Go. Go.
Somewhere like that. And when I estimate halfway between this, I get something like that. Now, what I notice is that these two perpendicular lines intersect at O, which means what is happening is that there's a rotation going on. If it was a reflection, what would happen is that the two halfway lines would overlap each other at one place. So if the two lines overlap, that would be the mirror line in which the object is reflected to give the image. But if they intersect crossing like this, it means that a rotation took place, and these two intersecting perpendicular lines is giving you the point of rotation. So I know that this is a rotation with the point of rotation being, the point of rotation being O. The point of rotation being O. And it is rotated by 90 degrees. As I say, OQ just moved 90 degrees from where it was. So this is a rotation. Now, if it was a translation, what would be noticed is that, all right, there's something called orientation. If you notice the orientation of this triangle, the original triangle OPQ, notice that QP is pointing upwards. But notice that its image OQ is pointed towards the west. You see? They are oriented in different directions. That change in orientation tells me that this cannot be a translation. In translation, there's no change in orientation. There's a change in position. So it's like I take something and I slide it on the screen without rotating or twisting it in any way for its direction, its orientation to change, or its sense of direction to change. Hopefully, we'll see it on another one. So the answer to this is definitely rotation of 90 degrees about the point O. All right? All right, so here we go again, around the ring, all right? Oh, sorry, I'm doing our maths thing. Yes. So this one says 301 can be written as, and of course, this one is clearly easy. The 3 here is 300, so that's 3, and 100 has 2 zeros, so that's times 10 to the 2. Right? Plus, this is 0 times 10. 10, and 10 is 10 to the 1, okay? 10 to the 1 is still 10. And then plus 1, which is 1 times 10 to the 0. Any number raised to the power of 0 is 1. So the 10 to the 0 is representative of the 1. So we get 300, 3 times 10 to the 2. And 1. And the, no, that's not it. So we have 3 times 10 to the 2 here. But here's the thing, we do not have any 10 to the 1. So you see this 1 times 10 to the 1 here? It cannot be. So here's our answer here. We have 3 times 10 to the 2. The 0 is going to cancel out that. And then we have 1 times 10 to the 0, which is 1. So that's 1. So it's A. As in Appolitos. Here we go. In question number 10. If P is equal to 3, bracket, open, of course, A to the minus Q, then 6A is equal to what? All right. There are ways we can look at this. But I think the best way of looking for this is, let's just try and find out what A is, and then we can multiply that by 6 to get what 6A is. I think that is fairly reasonable. So if we solve for A in P equal 3 bracket A minus Q, then if you look, all right. So we need to get rid of the 3 outside the bracket. The 3 is multiplying by the bracket. Let's carry it across and divide. Should we? Yes. So we're going to get P divided by 3 is equal to A minus Q. All right, I don't need the minus Q, the Q over here subtracting from the A. So we're going to carry it on the other side, and it's going to do the opposite, which is to add. So we have P over 3 plus Q is equal to A. So we found A. Now, if we want 6 times A, all of this that I have here, so I have to multiply it by 6. So I'm going to put P over 3 plus Q. We're going to put 6 outside, and we're going to equal it to 6A, right? 6 times P over 3, the 3 would cancel and give 1, and then cancel this and give 2, so we get 2P. And 6 times Q is 6Q, so it's 2P plus 6Q. Do we find that? 2P plus 6Q. We don't find out 2P plus 6Q. All right? Let's see the reason why. What they have done is they have further they have further simplified this unnecessarily. So, oh yes, see 2P times 6Q here, right here, so. All right. Let's clear that. Here we go again. Which of the following set is equivalent to A, B, C, D? Now we have equivalent set and we have equal set. Equivalent just means having the same number of elements. Equal means having the same elements and the same number of elements. So equal set means that each element is equal, but this is equivalent, which means it just needs to have the same number of elements. When I check this out, A, B, C, D is 4 elements. So I need another set with 4 elements, and this one has 4 elements. Woo-hoo. All right, so that has 4 elements. So that's the equivalent set. Let's take a nice little look on number 12. If Q equals set A, B, C, D, E, how many subsets can be obtained from set Q? How many subsets can be obtained from set Q? And the answer is, so we have 1, 2, 3, 4, 5. We have 5 elements, don't it? So then the answer is going to be 2 raised to the power of 5. And you're saying like, sir, like why couldn't be like, you know? All right, so let's imagine. So what is happening is that it should be 2 to the n. And n is the number of elements. Let's imagine that we had a set with no elements in it. The answer would be n would be 0, right? So 2 to the 0 is 1. And the amount of subsets we can get out of this is 1 empty set. What if we put 1 element in there? Like 1 element? If I put 1 element in there, let me use a different color. If I put an element in there like 2, how many subsets can we get? Well, the n now would be 1. So it would be 2 to the 1, which is 2. And I say like, sir, how you get 2 subsets out of this? Well, if you consider that the empty set is 1 subset and the set with the 1 element is another subset, that's 2 subsets. See what I'm saying? Let's go again. What if I put 2 elements in there like this? We have 2 elements, so that should be 2 to the n, which is going to give you 2 to the 2, which is 4, right? Or well, can we make the 4 elements? We have 1 empty set, and this is another symbol for the empty set. We have 1 set with 2, 1 set with 3, and 1 set with both of them. So you say that's 4 set. So that's what I'm telling you. I'm just trying to say to you that it's 2 to the n. And I was just trying to give you a little bit of testing. All right, here we go again. We have question number 13, clearly visible on screen right now. And in item 13, it refers to the following Venn diagram. Here we go. That is said. Pardon me. The capital U at the top mean universal set, all right? And that's the big set that all the little sets come out of, or all the, you know, other type of sets that can be derived from that big set will be written. Those derived sets are called subsets, by the way. I'm just, you know, going off on a little knowledge run right there. And one subset is H and one subset is V. Down here, they tell us that H are the students who play hockey. U, the universal, are the students that plays game in this, whether in the school, household, whatever that environment is, or that club is. And then we have students who play volleyball. Volleyball. Maybe that's a sport that much more of you can identify with. The number of students in each set is indicated. How many students do not play volleyball? And the obvious answer is everybody outside of the volleyball circle. This 3, is it in the volleyball circle? No, so we must circle it. Is this 5 in the volleyball circle? No. But is this 2 in the volleyball circle? Yes. And is this 4 in the volleyball circle? Yes. So it is this 5 and 3 that are not in the volleyball circle, and 5 plus 3 is 8. So the answer is 8. Don't be late. All right, so you won't have regret. All right. So that's the answer for this, because they asked us not. See them, and then put it in all caps too, you know. They didn't want you to miss it. I think Ray Charles could feel his way around that big nut right there. What do you think? All right. So let's go again. More set stuff. Here we go now. In item 14, it refers to the following Venn diagram that we're seeing. As I said before to you earlier, that U, capital U, means universal, and they're just saying that this is the bigger set from which the smaller or the derived sets are taken from, and we can clearly appreciate that. For instance, you in a big school, everybody in that school, you know, teachers, until workers, students, so on, that would be the bigger set, the universal set. But in that universal set, you can get subgroups or smaller groups or derived groups, like, you know, you can get the admin staff, you can get the ground staff, you can get the students, you can get female students, male students, you get the point, right? Of course you do. So let's go back here. The two circles above represent set P and set Q. If P equal factors of 6, and please remember that factors are numbers that contribute or make up another number. So they have to be smaller than the number that they make up or equal in size, right? It's like me saying, what are the factors that contributes to me being handsome? And you can say, okay, sir, you are brown like chocolate, you know, so that means you're sweet. Now that's one factor. But you see, that factor can't be the biggest thing, because there are other things that makes me handsome as well, you know, the airline and all that. Yeah, you know, the white teeth, you know, and you know, immaculate eyebrows, stuff like that. But you notice that each of those factors are smaller than the whole thing, which is me being handsome. So factors make up a thing, so they must be either equal to the thing or smaller than the thing. I say that to you so you don't mix them up with multiples where you keep multiplying by the same number. All right, so factors of 6 must be numbers that make up 6. Hello? And it's not make it up like anyone, like you're saying, like you can add and make it up. It's making it up by multiplication. But we'll get back to that. And then we have factors of 4. And then it says, so what does the shaded region represent? So let's just take a quick run through of factors of 6. So we can go 1 times 6 to make 6. And we can go 3 times 2 to make 6. And you agree, right? So basically, these 4 numbers that can multiply and make 6 are the factors of 6. And do you notice that none of the factors individually are bigger than 6? 1 is not bigger than 6. 6 is not bigger than 6. Oh, you say, but sir, 6 is equal to 6. That's not bigger than. All right? Okay. It's not bigger than 6. It's equal to 6. So that's the point I'm making. It's not bigger than 6. It can be a factor, right? So 6 is not bigger than 6. 1 is not bigger than 6, and they still multiply to make 6, of course. 2 is not bigger than 6, but you can multiply to make 6. And 3 is not bigger than 6, but you can multiply to make 6. These are factors of 6. They're built up, you know, they make up 6. All right. And then we have 4, which we know we can do 2 times 2 and 4 times 1. So obvious factors of 4 are 1, 2, and 4. And you say, sir, why don't I say 2 and 2? Because 2 and 2 is that's the same number. Why do I need to be redundant and say that over? Right? I never tell you that in maths, we love to write everything over and over. It's not a wheel. All right. So if we take a look now, in the shaded region where the 2 circles overlap, right, is where they have factors in common. So for instance, I noticed that the 1, let me find my favorite color, blue. I noticed that the 1 is here and the 1 is here, right? So I'll put the 1 right here in the shaded region there. So I noticed that the 2 is here and the 2 is here. So I'm going to put the 2 in the shaded region. But I don't see the 6 over here. So I put the 6. Oh, the 6 is in P? Yeah. Right here. And I don't see the 3 over here. So I put the 3 here and the 4 here. See that? So that's how I fill out the Venn diagram there. And in the shaded region, the overlapping region, the region that is common to both of them, we only find 1 and 2. And therefore, the answer must be B, as in ball. Bum diggity 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 bum. That's all the B I want to know. All right. So we're at 15. 15 and 16. They're about, yeah, 15, 16. All right. And I'm gonna, let me just clear the screen for you a little bit. And yeah, a woman buys a pair of shoes at a sale. Like, it's not, never mind. A woman buys a pair of shoes at a sale. She pays $45, saving $15 on the normal price. The percentage discount on the pair of shoes is, well, obviously, if she does not pay the $45 and she save $15, $15 is our discount or saving, right? Now, what should we compare the $15 discount to? Should we compare it to the new price or to the original price? Let me tell you this. It's when you're going through the consumer arithmetic and you're doing the comparing with a loss, profit, all of these kind of things, always compare to the original price, okay? Always compare to the original price. So in that case, it's going to be 15 over 45. And then if it's percentage, it's out of 100. So I'm going to times it by 100 to make it out of 100. All right. And 15 into 15 goes 1. I hear what I'm going to go by 5 first. They're both ending in 5, so they're divisible by 5. 5 into 15 goes 3. 5 into 45 goes 9. And then they are both divisible by 3 into 3 goes 1. And 3 into this goes 3. So, of course, this is 1/3. So the answer is 33 and 1/3. And I said, sorry, just jump go there, so. All right, I'm sorry. I should have tell you. That is, if you have 100 divided by 3 like this, 3 into 10 goes 3 times, remainder 1, which means 3 into 10 goes 3 times. So that's 33, which is going to be remainder 1, which is 1 over 3. See that? So 33 and 1/3%, as I was saying to you before. You got to know to divide. You got to know when to add them, know when to divide. Anyway. All right, so let's go. Number 16. Tom bought a pen for $60.
I don't know.
And sold it again for 20% off its cost price, which should have been in the original price as it relates to Tom, by the way. How much money did he gain? So he bought it for $60. So let's find 20% off $60. We know that percentage is out of 100. So this is 20% out of a possible 100%. And if I just, in a little bit of a sense, just throw that over 1 there, I can see 0 canceling 0, 0 canceling 0. And of course, what we're ending up with is 6 times 2, which is 12. Right? So $12 is how much money is going to gain in profit. Right? And I see that answer right here at A to the appletos. Yes. I don't think you can use my word for free. You might find that I've copyrighted it. Appletos.
Wrong.
I'm just messing with you. You can go ahead and use the word. I'm lending it to you. All right, here we go again. Now, during a sale, a shop allows 20% discount off marked price of clothing. 20% discount. What will a customer pay for a dress with a marked price of $30? All right, so let's take a look. So during a sale, shop allows 20% discount off the marked price of a clothing. What will the customer pay for a dress with a mark price of $30. So let's see now. So $30, she's going to take off 20% discount, which means she's going to pay 80%. If you take 20% out of 100, you only have 80% left. So she's going to just basically pay 80% of the dress. So we're going to say 80%, which is out of 100. And that's what we're going to be working out. You know what I mean? Who likes to see a little bit of green? Let's do a little bit of green in this. So that 0 cancel that 0, that 0 cancel that 0. And we have 3 times 8 is $24 of manners. Know yourself. Answer right there at C. See? All right, let's go again. Question number 18. A customer buys a table on hire purchase. Hire purchase. If you know anything about hire purchase, is that you must have a deposit that you pay down, and then you pay the rest of the money in installments, and that installments would include the interest and the balance that you owe. Yes, you owe the people them their money. They then put interest on it and divide it up into smaller payments so you can afford it, because of course they want your money. Yeah. So a customer buys a table on hire purchase. He makes a deposit of, see that, them say it already, deposit of $306 and pays 6 monthly installments of $60. What is the total cost that the customer pay? It, of course, is the $306 plus the 6 times 6 installments. So if they pay the 6 installments 6 times overall, that is 6 times 60, which is 360. And my God, what kind of number this? You see what them do? 6, 6, 6. Hey, hey, hey. Better not be superstitious right now. But them actually the 666 in the maths question. All right, no problem. Let's move on. Okay, let's have the 666 business. All right, so we are at these 2 questions. So here we go now. A dinner in a hotel was advertised at $60 plus 18% tax. The total bill for one dinner is, of course, if you're going to buy that one dinner, you know, there's 2 approaches we can take. We can find the 18% tax of the 60. And please remember, when you pay tax, you pay more. If you want to pay less, get a discount. You understand me? But if you're going to pay tax, you're going to pay more. So the money is going to, so if you thought that your bill was $60, it's going to be $60 plus tax, which means tax is added on, right? So that means you're going to pay your 100% of the $60 plus 18% more of it. So that's 118%. Or what we can do is we can find the 18% of $60, then add it to it. Let's take that approach because most of you are used to that, in a sense. So $60 times 18%. Many people's favorite color is red, so let's just use that. The 0 cancel the 0 right there. And 2 into 10 goes 5 times. And 2 into 18 goes 9 times. And what we're going to end up having is 9 times 6, which is 54. Divided by 5. 5 into 50 goes 10, or, put the 1. 5 into 4 goes 0. And then 5 into 40 goes 8 times. So it's $10.80. So this is the tax money. And what did I say? When you get tax, you are paying more money. So this is added on to the $6, and we get $70.80 in the B unit. Right there, right? So just right there, right at that place right there. So all right. Okay, the simple interest on $400 at 5% per annum for 2 years is given by, if you remember the simple interest formula, it is where they say that SI, which means simple interest, in case you didn't know, is going to equal to P, this is the principal amount that you put in, R, which is the rate in percentage per annum, and T is time in years all over 100, right? And if we go now, it's going to be 400 times the 400, which is the principal, times the 5% times the 2 years over 100. And that's this one right there. So don't go no further. All right. So A as in Appolitos. So I'm going to clear that. When we reach to question 30 on this, we're going to take a look at the longer paper approach, right? So here we go now. If the simple interest on $800 for 3 years is $54, what is the rate of interest per annum? We go back to the very same formula. SI, simple interest, is equal to P T over 100. Do you see? And if we follow this, they gave us that the simple interest on $800. So I have P that it is $800. And I have T, which is 3 years, but I don't have the rate. So I can put back R, and I can times it by the T, which is 3 years, over 100. And then they told us that they told us already that the interest is 54. So instead of writing SI back, I'm going to write 54. Why? Because I know what SI is already. It is 54. And so now we're looking for R. I notice, yes, I do notice things in case you didn't know. Some people like pink. No, pink is just too close to that. These 2 zeros cancel these 2 zeros, yeah? And 8 times 3 is 24. So I'm going to move that 8 times 3, which is 24, that is multiplying by the R, across on the opposite side to divide. So I'm going to end up with 54 divided by 24 is equal to R. Right? And, you know, I realize that these two things are divisible by 2. So 2 into 24 goes 12. And 2 into 54 goes 27. And then I realize that these both are divisible by 3. 3 into 12 goes 4. And 3 into 27 goes 9. And then I realize that 4 into 9 goes 2 times remainder 1. That 1 can become a 10. 4 into 10 goes 2 times. Remainder 2. 4 into 20 goes 5 times. So I'm looking at 2.25 or 2 and a quarter, right? And that is this right here, 2 and a quarter %. Here we go now on question number 23. The expression y is equal to the square of x can be written as, so y, don't ask me, don't ask that. That's what they said. They said y, and I don't, should I have an answer? Is equal to the square of x. The square of x, not square root, you know. The square of x. So this is x and this is the square of it. Y is equal to the square of x. That is it. And that answer is Appolitos A. Okay, let's take a look at 24 and 25. All right, here we go now. If we take a look at 24, the expression is minus, so the number outside the bracket is going to be distributed by multiplication to everybody inside the bracket. And guys, please remember your sign. Don't go up to that T-junction in the road and ignore the stop sign and run out in a bicycle. Stop, look and listen before you go to the road or across the road. I know you guys don't really remember. Most of you drive in vehicles, so you don't know to stop, look, and listen. Somebody else do it for you on the steering wheel. All right. -2 times x is -2x, but negative times a negative is a positive, and 2 times 4 is 8. So we're looking at -2x plus 8. So that is D as in dog doodle. Yes. Can be quite messy if you mess up the signs.
The dragon. No.
Yeah.
It's not the dragon.
Real bad, isn't it? All right. Now, when 7 is added to 3 times a certain number n, I hope you get what it says now. When n is added to 3 times a certain number n, the result is 22. So we can first write n is added. No, 7 is added. So 7 is added to what? 3 times a certain number n, which is 3n, right? The result, which means that it's equal to 22. So we're looking for something that looks like this. Where do we see this? Boom. That's it is right there in Apollidos. So it is, yeah. Let's get back to the 26. Now, John. Why is it always got to be you, John? John had X marbles and Max had twice as many. Max gives Tom 5 of his marbles. How many marbles does Max now have? Okay, so let's look at John now. So we say that John has how many marbles? So John has X marbles. I'm going to put X right there so for John. And Max had twice as many. Which that means Max has 2 times what John has, which is X. So it's 2 times X, right? Max gives 5 of his marbles to Tom. How many does he have? He has the 2x, but now that he's giving 5 away, it's going to be 5 less. So it's 2x minus 5, which is taking a deep dive into the letters of D. All right? Now, given that P star Q means 2Q minus P, the value of 1 star 2 is, all right, so when it says P is the first number applied with the function to the second number. It's going to turn out that you're going to double the second number and then subtract the first number. So what does that mean? It means that the 1 should match to the P and the 2 should match to the Q. So if that is the case, the 2 matching to the Q, this becomes 2 bracket 2. 2 goes in the place of the Q minus 1 goes in the place of the P. 2 times 2 is 4. And that minus 1 is 3. See that? So the answer becomes 3. And it has cat-like reflexes on the cataclysmic C.
Dad.
All right. Here we go again now. The expression 2a cubed is the same as. Now, we can take 2 approaches to this. Suppose I wanted to let you understand the meaning of the indices. So this power outside, this little tree right here, it means that the 2a is going to be multiplied by the 2a is going to be multiplied by the 2a, which means 2a is multiplied 3 times. That's why I have this little tree up here. So, and 2 times 2 is 4 times 2 is 8. And 8 times a is a squared times a cubed. So 8a cubed. So that's one approach we could have taken. And this is very much correct. All right. The other approach you could have taken is that the power inside multiplies the power, the power outside the bracket multiplies the power inside. So this becomes 2 to the 3, a to the 3, 2 to the 3 is 8, and then we have 8 to the 3. Whichever way you take it, the answer becomes that. Number 29, if 5 bracket 2x minus 1 is equal to 35, then x equal, we have 5 bracket that, then x bracket, well, okay. So 5, we need to get rid of this 5 here. We can multiply and expand the bracket to get rid of the 5, or we can just simply carry it across and do the opposite of multiply, which is to divide right there. And what we'd end up with is 2x minus 1 is equal to 35 divided by all right, so this becomes now 2x minus 1 is equal to 7. Now, looking at it a little bit further, I still want x by itself, but you see this minus 1 here, it needs to go. It needs to go. And since it's subtracting on this side, we're going to add it, bring it across and do the opposite of, which is to add on the other side. So we have 7 plus 1. All right. Then you see this. X is equal to 8. And then finally, x is equal to 8 divided by the 2 that comes across to do the opposite, which is 4. So x is equal to 4, which is this right here. Here we go now. And this question 30 is a simultaneous equation. The sum of x and y is 18. So what does that mean? The sum of x and y. X plus y. Remember that sum means to add. The answer you get from addition, okay? And their difference is 14. Okay. Now it says which pair of equation describe these? And it is C. And that's the question 30 right there, right? All right, so this is where we're gonna jump over. Take a look at, and please make sure these guys, you see these things here? These formulas, get familiar with them, get using them, get cracking, being not cracking. All right, they say using a calculator otherwise, so all I do is you calculator savvy people out there. This is your chance. So you ready now? It say using your calculator otherwise, calculate the exact value. Also, and only 2 months. Oh, this man modern this. I'm not saying no. All right, so what is gonna go on here now? All right, so I noticed that you see whatever 3 can go into whatever 6 can go into, 3 can go into, because 3 can go into 6. You understand? So let's find an LCM for all of these numbers now, quick and fast. Between 6 and 7. And that is 42, right? But just before the 42, there's something else. I want to change these mixed fraction into improper fraction. So 7 times 1 plus 4 is gonna give me 11. 6 times 1 plus 5 gonna give me 11. All right, so now here we go now. What do we multiply 7 by to get 42 right there? And you'd have to agree that it is all right, so you should be saying 6. And that means we're going to multiply this 11 here by 6 to get 66. What do we multiply 3 by to get 42? And 3 into 4 goes 1. Then 3 into 12 goes 4, 14. So it's 14 times 2, which is 28. Right? And then last but not least, how many times does 6 go into 42? 7 times, or we multiply 7 by 6 to get 42. So what we're gonna have now is 77. And please note the sign coming back here. Oh, sorry, mistake was made when I wrote this. All right, 2 plus 60 is 80. And 6 plus 8 is 14, so that's 94. Minus 77 over 42. 70 from 90 is 20. So we have 24. And this leaves 17 over 42. All right, 17 over 42, and we collect our 2 marks, 1 mark for this final step, and this other mark for the layout to get to the answer. This one says, write the value of the cube root of 27 over 9 squared as a fraction in its lowest form. All right, so let's take a look at that. So it's the cube root. It's not square root, it's cube root. So it means which number that multiplies by itself 3 times will give 27. And that number is 3. 3 times 3 is 9, and then that 9 times 3 again is 27. All right, so the cube root of 27 is 3, and the square of 9 is 81. All right, 3 into 3 goes 1. 3 into 8 goes 2 times. Remainder 2 to make 21. 3 into 21 goes 7. So the answer is 1. I will get our 2 marks for this. 1 for showing that we know to properly use the cube, the root sign and the square. All right, here we go again. The thickness of one sheet of cardboard is given at 485 times 10 millimeter. A construction worker uses 75 sheets of the cardboard stacked together to insulate a wall. Show the exact thickness of the insulation is 363.75 millimeter. All right. So here the question is, the thickness of one sheet of cardboard is 485 times 10 squared millimeter. A construction worker uses 75 sheets of cardboard stacked together to insulate the wall. Show that the exact thickness of the insulation is 363.75 millimeter. All right. Here we go now. Firstly put, you see this 4, 8, 5 times 10 to the minus 2. The negative sign in the power also means divide. So if I keep dividing by 10, the decimal point is going to jump 1, 2 places. And I end up with 4.85 millimeter. All right. Now, this now would be the thickness of one sheet of card. So to get the thickness for 75 sheet, we simply put 4.85 times 75. All right, let's go now. 5 times 5 is 25. I'm gonna put on this 5. Carry the 5. All right. 5 times 8 is 40 plus the 2, that's 42. And 5 times 4 is 20 plus 4, 24. And then remember that this is 2 decimal place. All right. Multiplying by the 7 now. Okay. So put a 0 here. Then 7 times 5, 35. Run the 5, carry the 3. 7 times 8 is 56. Plus the 3, that's 59. Carry the 9. Put on the 5. 7 times 4 is 28. Plus that is 33. And it's 2 decimal place. So boom. And then now we simply add in 0 and 5 is 5. 5 and 2 is 7. Put back the decimal point. 9 and 4 is 13. Carry the 1. This is 6. And then this 3 comes down. And this is the amount in millimeter. And you see, we have proved exactly what they have said here. All right. So it says now, write the thickness of the insulation character 2 significant figures. So if I should take a look to 2 significant figures, now please remember that significant figures is not about where the decimal point is. It's simply about numbers other than 0. All right? That are considered to be significant. So this is the first figure here, and this is the second figure, and we're going to check the third one. So this is going to be 360, not 36. Remember, the number is 363. So I'm running it off to the nearest 10, which is where the significant figure goes. So it's 360 millimeter to 2 significant figures. So that's the answer for this. And there's a character 1 decimal place. So this is 1 number after the point. And to 1 decimal place, it is 3, 6, 3 point. I have to check the second decimal place to see if we're going to round up or remain. And it's 5 or more, and we round up. It's 5, so we're going to round up, and it becomes 8 millimeter. All right. And this answer is related to this one, 1 decimal place, right there. Okay. They say we should write this number in standard form. All right, so let's go again. All right, so in standard form, we only want 1 number below the beyond the point. So we're gonna jump this decimal point 1, 2. So it becomes 3.6375 times 10 to the 2, because we only jump 2. Now, the question is, to know if it is positive. Is 363 greater than 1? It positively is greater than 1. So the power is positive. So this is the answer right here. All right. And this answer applies to that. Writing the answer in standard form. Which we did some amount of this earlier when we were taking a look at the multiple choice questions, didn't we? Yes, we did. All right. Let us see. It says Marco is on vacation in the Caribbean. Ooh la la la. He changes 4,500 Mexican pesos MXN to Eastern Caribbean dollars ECD. He receives 630 ECD. Complete the table below about the exchange rate. All right, so let's first do this one right here. So this is one of those things that we call the direct proportional thing. So for 500 MXN is equal to 630 ECD. All right. So they say, what is 1 ECD? Now, here's the thing. If I want to get 630 to become 1, what should I divide by? Obviously by itself, right? So if I divide 630 by 630, a number in itself goes one time. But then to keep this thing the same ratio, I must divide this side also by 630. So this will cancel out to give 1, which is the 1 ECD right here. But then this over here will give 63 into 45. You can go ahead and do that and give me the answer if you're there. Take you guys long enough to give me the answer though. All right, so it's 12.5, but remember this is money, so it should be $12.50. All right, so you go to 2 decimal places for money, okay? So 1 ECD is $12.50. And I gave a nice little 9 marks for that. Okay. Don't worry, we're at question 2 for the same paper. It says factorize the following expression completely. All right, so when I take a look at this, I realize that I can divide 4 into 12 and I can divide 4 into 4. So I'm going to write down 4 here, right? I realize that I can get n right here in n squared and I can get n in mn. So I'm going to write n right here. Open a bracket. 4 into 12 goes 3 times n. Cancel out of n squared, will leave n. 4 into 4 is going to, into negative 4 is going to give -1, because remember, positive times a negative is a negative down here. And 4 into 4, 1. N into mn is going to give, the n into n will cancel and leave the m. So in essence, what we have is 4n, open bracket, 3n minus m. We don't need to put 1m. 1m is the same m. All right? And you get 1 mark for doing that nice little thing there. Here we go again. It says, show that x over 1 minus x minus 4x is equal. Oh my. They are playing hardball. All right, no problem. So we go now. X over 1 minus x minus 4x is supposed to be equal to x. So we just need to get 1 to look like the other one. And what? I wanna. It's gonna 1 minus 3, right? Now what we're gonna try and do, we're gonna try and make this fraction over here become one fraction. All right? So if I just put this over 1 like this, I realize I need an LCM, and the LCM is gonna be the 1 over x. Like, okay, so let me show you. So 1 minus x, right? And that's gonna give me x minus 4x bracket 1 minus x. And you're saying, sir, oh, you get this 1 minus x. Well, think about it. What would I have to multiply 1 minus x by to get 1 minus x? 1. So 1 times x up the top is 1. But what would I have to multiply 1 by to make it into 1 minus x? 1 minus x. So the top number at the top has to be multiplied by 1 minus x. And that is going to be equal to x over 4x minus 3 over 1 minus x. And please note, you may be observing some graphic error here, seeing a tree. It's not supposed to be that way. It's supposed to be x. All right, so if we complete this thing over here, let's simplify up the top. X minus 4x times this 1 right here is going to give me negative 4x. And then this times this is going to give me plus 4x squared over 1 minus x, which is equal to x bracket 4x minus 3 over 1 minus x. All right, so we see the 1 minus x in place, so we need to see what is going on up top right here. So, oh, hold on. Oh, yeah. All right, now I noticed that these two are like terms. So I'm going to end up with negative 3x plus 4x squared over 1 minus x is equal to x bracket 4x minus 3. And please remember, the aim is just to make one look like the other. And I chose this way because you guys don't really like fraction. I notice now that I can factorize this thing here. The one over on this side. And if I should do such, I should get x bracket negative 3 plus 4x over 1 minus x equal to x bracket 4x minus 3 over 1 minus x. And if you notice, it's the same thing now. It's just that all I need to do is just rearrange these two, put the positive one at the front and the negative one at the back, and it's exactly the same. So we have proven this, okay? And they were given 2 marks for that. Mercy. That's the people who relentless. All right, here we go. And let's say ends solve this. Them and them solve. All right, let's do them solve now. No? First thing I notice, X is all over the place. I have X here, I have X here, and I have X here. I don't want so many X's in the picture. See what I mean? So what I'm going to do is I'm going to bring this one over here at first. So I'm going to have X over 1 minus X is going to be equal to positive 4X. And you're saying, sir, why positive? Well, if it's subtracting over here, it must go on the opposite side to add, right? So yes. And if you add it to 0, it is of course itself. Then now this one down here that is divided, we're going to carry it across and multiply. So we have X is equal to 4X, open bracket, 1 minus X, such and such, right? And then from here now we can do this and say X is equal to 4X times 1, which is of course 4X. And 4X times minus it is negative 4X squared. All right. And from this, we can take this other one over on the other side. And it's a nice little quadratic here, where we have negative 4X squared plus 4X minus X, because this X on the left-hand side comes over on the right-hand side to do the opposite, which is to subtract. So 0 is equal to negative 4X squared plus 3X. Now, what I'm going to do here now is all right, we can factorize this. X bracket negative 4X plus 3. So the answer now is either X is equal to 0, and if X is equal to 0, 0 times the bracket will make everything 0, right? So it's either X equals 0 or negative 4X plus 3 is equal to 0, where in that case, negative 4X is equal to minus 3, because the 3 goes over on the other side and subtract instead of add, where now X is equal to positive 3 over 4. And you want to get positive, because when this negative 4 go over and divide, negative times a negative is a positive, and we'll get positive 3 over 4 or 0.75. So those are the two answers. This one and that one. And that's what they're giving, though. All of that work just for those nice little 2 marks. All right. I'm going to clear that. Make V the subject of the formula. We're going to try and make V the subject of the formula here. So we're P is equal to the square root of 5 plus VT. Now, the first thing I notice is that V is under square root. I need to get rid of the square root. Now, the opposite of square root is square. So I need to square both sides. And if I square both sides, this P become P squared, but the square root disappears on the right-hand side, and I end up having 5 plus VT. I want the VT, the V by itself, which is with the T. So I can carry the 5, which is adding and it subtract. So we end up with P squared minus 5 is equal to VT. I want V and not VT. So the T, which is multiplying, will go across and divide. So V is going to be equal to P squared minus 5 divided by T, and they give you 2 marks for that. Enjoy yourself. Okay, so let's take a look at this one now. It says the distance needed to stop a car, D, varies directly as the square of the speed. So the distance to stop a car, D. So D varies directly as the square of the speed, S, at which it is traveling. All right, so that is the first thing. A car traveling at speed 70 kilometers per hour requires a distance of 40 meters to make a stop. All right, so look here now. So this, sorry. So a distance of 40 meters will map to the square of 70. 70 kilometers per hour. And we're gonna square this. Why are we squaring this? Because that's what this thing that we wrote down right up here said. And then now they ask, what will happen if the car was at 80 kilometers? So we'll just simply put D maps on to 80 kilometers per hour square. All right, so here we go. Now here we have the 2 case again, like I showed you earlier. And you can simply cross multiply that times that. All right. Now 40 times 80 squared. 80 squared is gonna be 8 times 8 is 64. You know, and 10 times 10 is 100, 6,400. And that's gonna be equal to 70 times 70 is gonna be 4,900 times D. Like that. And of course, if we want D by itself, we must remove the 4,900 to go and divide into the 40 times 6,400 divided by 4,900. And in some sense, I'm just now realizing that probably was better if we didn't, multiply all of these things initially. All right, so we have this now. And so we just divide this now. 40 times 64 equal to 200 and yeah, whatever. Divided by 49. And this is equal to 52.2 meter. All right. So this is the answer, 52.2 meter. And I said, sir, why stop at 0.2? Because most times CXC just, if they didn't tell us, we just go to 3 significant figures. 5 is one figure, 2 is second, and the third figure is the 2 rounded off at that place. And they gave us some nice little marks for that. Here we're going to go to question number 3. And in question number 3, it says it shows the diagram below shows 2 pentagons, P and Q, drawn on a grid made of squares. All right. Select the correct word from the following list to complete the statement below. So select the correct word from the following list to complete the statement below. All right. Let's start selecting words now, yeah? All right, so notice, so let's look at, it says opposite. Are they opposite each other? No, they're not. Because notice one is shaped with the, all right, so notice that the 2 short side. One of the short side is 2 and one of the short side is 3. So this one here is 3, this one here is 2. So if we look at the 2, 3 arrangement, if we look at the 2, 3 arrangement, the one for Q points upward and the one for P points westward. So they are not in the same they're not in opposite orientation. So they're not opposite. Are they congruent? Which means that are all the dimensions the same size? So on this back side right here, so we see 5 squares long, and this one up here is 5. And then both are, yes, so they are congruent. Were they translated? No. Remember I tell you that translated, they'd have to be in the same orientation. But one is set pointing north and one is pointing west. They're not in the same orientation, so they're not congruent. Were they reflected? No, if they were reflected, they'd be opposite. So they were actually rotated again. So they were probably rotated about this point right here in the anti-clockwise direction, 90 degrees. In any essence. That's grip of the silk. So pentagon P is congruent to pentagon Q. All right, which means they're the same size and the same dimensions and so on. Give the reason for your choice in AI. And the reason for our choice is the sides have the same, the 2 figures, P and Q, have the same dimension for their sides. All right, the same dimensions for their sides. All right, this question now B. More diagram stuff to go about. The diagram below, not drawn to scale, shows the pentagon. Pentagon from penta meaning 5. BWXYZ. In the pentagon, YZ is parallel to YX. So YZ, where is YZ? This is YZ right here. It's parallel to XW. That's that, right? And YX, which is this, is parallel to VW, which is that, right? Okay. Angle XYZ, X to Y to Z, is 114 degrees. That's this right there. While angle VZ, Y? VZ, okay, so that's that angle right there. Okay? So they ask the question now, determine the value of the angle W, X, Y. So they say determine this angle right here, so. All right? So how do we determine that now? How do we determine that? All right, so let's go now. So I'm going to do some little trick shots. Did I call them trick shots? I guess I did. All right, so I'm going to extend this line here for some good reason. I'm going to extend that one there for some good reason. All right? Now, why did I do that? Now, angles on a straight line are supplementary, which means that they add up to 180 degrees, right? So the angle here is theta. No, but look at this. Parallel lines. So you notice that this line and this one are parallel. So that means this line will cut them at the same angle. So this theta here is equal to the same theta right here. So all I have to do is 180 degrees minus 114 degrees is going to be equal to 66 degrees. So that's the answer. The answer is 66 degrees. Why? Corresponding angles in a line transversal are equal. And the angle at X is corresponding to the angle at Y here. And then now angles on a straight line adds up to 180 degrees. So I know that this is 66. And since these are corresponding, they are equal. So this is also 66. All right, I'm supposed to find angle ZVW. I'm supposed to find angle ZVW, which is this angle right here. All right. I remember we found this one right here, so to be 66 degrees. All right. Okay, so that's 66 degrees. Now, there are multiple approaches to be taken here, but I think the simplest one is first to realize that the angle right here is also corresponding to the angle at x. So this is 60 degrees, 66 degrees, which means that this here is 114 degrees, okay? All right, so that angle here is 114 degrees. So if you notice now, in the pentagon, I have 4 angles and only 1 angle is missing. So if I know the total number of degrees for all 5 angles, then I can add up these 4 and subtract it from that total to find out the missing one. What do you say? So there's a formula that they have that tells us the total number of angles. Yeah. Or, hold on. Instead of going that route, watch this. I'm gonna extend this. And I'm gonna extend this. And it forms it completes a parallelogram of sorts. Do you see? And if it's a parallelogram, opposite angles are equal. So it therefore means that this angle is equal to that angle here, which means that this is 66 degrees. And you're probably saying, so sir, why you need to know that angle there? Because what I'm going to do, I'm going to use the angles in this triangle to find it. So if this is 98, 98 from 180, that's going to leave 72. No, I leave 82, sorry. So this is 82 degrees. And then these 3 angles must add up to 180 right here. So 82 and 66. So this is 148. And that will leave what? 32? So this angle here is 32 by virtue of that. And if it is 32, then it means that this angle here is 148 degrees. Oh, that was a lot of rules used up. All right, just going back to the other idea talking about the 5 angles in the pentagon adding up to some total. So there's a formula that we have that can give you the total number. So we know that the triangles in a triangle is supposed to add up to 180, right? So the formula goes something like this. Okay, so so 180 degrees in minus 2 is equal to the total. All right, let's see if this works. So for a triangle, it should be 180, right? N is the number of sides. So Triangle has three sides. 3 minus 2 is 1. 1 times 180 degrees is equal to 180. So the triangle must, three angles must add up to 180. Quadrilateral has 4 sides, and the 4 sides must add up to 360 degrees. So 4 minus 2 is 2. 2 times 180 is 360. But a pentagon has 5 sides, and so it should be 5 minus 2 times 180. And that is going to be equal to 3 times 180, which is 540 degrees. So all 5 angles of the pentagon is supposed to add up to 540. And if we were to subtract the sum of these other 3 angles that we had found, these 4, and subtract it, we should get this 5th angle here, which is still going to show to be 148, by the way. But let's do it anyway. So we have 114 plus 114 plus 98 plus 66, 392. 392. Subtract it from that, and you get 148 degrees. All right. So either way you take it, the angle at ZVW is 148 degrees. And I go carried you through all of that. Wranglings to get it. That's with that geometry part. Let's just finish this coordinate part and close the show. The letter A and the point C, which is 6, 6, are shown on the grid. All right, and if you're wondering where's the letter A, here's the letter A right there. And here's the point 6, 6. All right. It says, so these are they. On the diagram, draw accurately each of the following transformations. The enlargement of A by a scale factor of 2 about the center C. All right, so let's do that now. So let me draw for my straight lines. So I'm going to draw a straight line right here, so through one of the points of A. All right. Then draw another straight line through the other point of A like that. And then one more straight line so you could do this with your ruler, all right? So they say using the center 6, 6. All right, then now. So the question then is going to be, what we'll do, we can measure. There's 2 ways we can do this. We can measure the sides, but I don't think that's the best way. The best way is to measure how far we are from the center. All right? So if you notice, we went down 4 by 1 to get to this side here. So what we're gonna do is double that and go down. We need to, okay, yeah, 4 by 1 again to double that. And then this is where it is at. This is where point A is. And it's going to go up to here, okay. All right. And then this one was 4 by 3. So I'm going to go 3. Oh yeah, one more thing. Oh, this, which was a little bit above halfway. All right, so there is the A enlarged twice using the center. See, all right, so if you're wondering what I did, I simply measured off. Let me change this so I can show you what I'm saying. I measured off the distance from here to here. Then I measure that distance again here. Now, when I did it like this way, for A, it would have been X distance from the center, but for A prime down here would be 2X. The distance would be 2X from the center. And I did the same thing here again. The peak here from the center, and then I double it, go one more. And now it's double the distance from the center. And the same thing for the point here. And we'll do the same thing for this point and so on. All right. They say the translation of letter A using the vector -3, 2. All right. So the translation of the letter A using the vector -3, 2. All right. So here's how we're gonna do that now. All right. Every point for A, we're gonna move it 3 across to the left and 2 up. And you say why? Because you see this -3 right here? That means you're moving 3 on the x-axis in the negative direction. And this 2 down here means you're moving 2 on the y-axis in the positive direction. Positive is up, negative for the x is to the left, okay? So here we go now. 1, 2, 3, then 2 up. So the point is right here. See that? Then this point now is going to be 1, 2, 3, then 2 up. So the point is right here. This point is going to be 1, 2, 3, then 2 up, 1, 2. So the point is right here. See that? And if I should complete this drawing, all right? So this is the translation of the letter A. Now notice that the A still looks upright, pointing upward and down. It's just that you have to just take it and slide it to a new location. So that's how you know when it's translation. All right. This is where we close the show today. So we have completed up to question number 3. And what paper was this? This is January 2021. All right, so very recent paper. And we see how we do the enlargement and so on. I hope we all had fun while doing this today. And I hope to see you again very soon. We have some more exciting times to come. This was just simply an introduction of what can happen and what will happen. And of course, as you know more, we can do more. And as we do more, we can know more to do more and get more in our exams. All right. Thank you guys for joining in. And see you soon. This was just simply an introduction of
Absolutely.
what can happen and what will happen. And
Thanks much, Mr. Grant. You hear me?
Yes, I'm hearing you.
Yes, thanks much. All right, guys. And if you're interested in joining our math class, it's normally on Sundays, 2 to 4. You can reach out to us at 202-6446. All right. Take care.